screen in front of him was the color of a dying television, that flat, institutional grey-green that scientific instruments wore before anyone thought to make them beautiful, and across it, the data was crawling in from a pass that had begun over the Southern Ocean 20 minutes earlier. It was late. The room was cold in the way that server rooms are always cold, the air moved by fans that never stopped, and the man watching the return was doing what he had done 1,000 nights before, which was almost nothing. He was waiting for numbers to resolve into a line, and then the line bent. I want you to sit with that for a moment before I tell you what it was, because the sensation of that night was not discovery. It was wrongness. It was the specific unease of a person who knows an instrument intimately, who knows exactly what it should say, watching it say something it has no business saying. The gravity field over East Antarctica is supposed to be boring. It is supposed to be smooth. Beneath 2 vertical miles of the thickest, oldest, most crushing ice on the surface of this planet, the rock is supposed to behave, and the number that describes how hard the Earth pulls at that particular patch of nowhere is supposed to sit there, quiet and flat and unremarkable, all the way to the pole. That is the entire point of a place like Wilkes Land. Nothing happens there. Nothing has happened there for a span of time the human mind cannot actually hold. But the field was not flat. As the pass ran south, the value began to climb, and it did not climb the way a mountain range makes it climb, or a buried lake, or a fault. It climbed toward a center. It rose in a smooth, deliberate, almost patient curve, pulling upward as though the instrument were being drawn toward something, and then it crested and fell away on the far side in a mirror of the same curve. And what that shape described, once you plotted it, once you let the numbers become a picture, was an edge, a boundary, the rounded rim of a mass so dense and so concentrated that it was bending the local pull of the entire planet toward itself, like a stone dropped into the middle of a still sheet, and the ripple frozen in place. They measured it. Not that first night, but in the passes that followed, and in the older records they went back and reread once they knew what they were looking for, and the size of the thing is the part I still cannot make sit comfortably in my chest. It is roughly 300 miles across. Let me say that in a way you can feel. If you stood on its western edge and set out walking east across it, you would walk for days. It is larger than most of the countries you could name. It is a single discrete body, buried, coherent, with a defined margin, and it is denser than anything the crust of the Earth is supposed to be able to hold. The crust around it is ordinary rock, granite and gneiss, and the tired bones of an ancient continent. And then, without warning, there is this, a wall of mass a mile and more beneath the ice, heavier per cubic foot than its surroundings by a margin that no ordinary geology comfortably explains, sitting in the dark where no light has ever reached it and no human hand has ever come close. The people who process gravity data are not romantics. They are not the sort to gasp at a screen. Their entire discipline is built on the assumption that the strange reading is your fault before it is the Earth's, and so the first response, the correct and professional and deeply human response, was that the machine was lying, a calibration fault, a drift in the accelerometers, a ghost introduced somewhere between the sensor and the storage, the kind of artifact that has embarrassed careers. You do not announce a 300-mile object under Antarctica on the strength of one anomalous curve. You assume you have broken something and you go looking for the break. And this is where the story turns, quietly, the way these stories always turn, because they could not find the break. They checked the instrument against known fields, the places on Earth where the answer is already carved in stone, and over those places the instrument was flawless. It read exactly what it should read, to a precision that is genuinely difficult to comprehend, measuring changes in the pull of gravity so small that they correspond to the movement of water and ice across whole continents. The machine was not broken. The machine was, if anything, too good. It had done precisely what it was built to do, which was to feel the invisible distribution of mass inside the planet, and what it felt, out there under Wilkes Land, was something enormous and heavy and utterly out of place, hiding exactly where nothing should be hiding. I have spent a long time inside this material, longer than I meant to, and the thing that keeps me returning is not the size, And it is not even the density. It is the edge. Mantle heat, deep rock, the ordinary machinery of a living planet, these things blur. They fade at the margins, they diffuse, they have no clean line where they begin. This has a line. The curve in that first gravity return was not the smear of something slowly welling up from below. It was the rim of a body with a shape, a thing with a boundary, sitting in the crust the way a coin sits in the palm of a hand. Something that is there and then, at a definite place, is not. So hold the picture. A mile of ancient ice, blue-black in its depths, pressing down with a weight that has flattened the continent beneath it. And under that, in the rock, in the total dark, and the total silence where the temperature never changes and nothing has stirred since long before there were eyes to see it, a mass 300 miles wide, denser than the world around it, curved at its edge, pulling the whole gravity field toward its center like something with a slow, buried heartbeat. A man sat in a cold room and watched a line bend on a grey-green screen, and that was the first time anyone knew it was there. He did not yet know what it was. Neither, if I am honest with you, do we. But the reading was real, and the thing was real, and it had been waiting under the ice a very, very long time before that line began to climb. To understand what that bent line meant, you have to understand the machine that drew it, because it was not a machine that looked at anything. In March of 2002, a rocket lifted off from Plesetsk in northern Russia and placed into orbit two identical satellites, flying one behind the other, roughly 220 kilometers apart, in a formation the engineers who built them called, with a kind of grim tenderness, Tom and Jerry. Officially, they were GRACE, the Gravity Recovery and Climate Experiment, a joint effort of NASA and the German Aerospace Center. They carried no cameras that mattered. They took no photographs of the ground. All they did, all they were built to do, was watch each other. A microwave beam ran constantly between them, measuring the distance from the trailing craft to the leading one with an accuracy of about 1 micron, roughly the width of a single blood cell, across 200 kilometers of empty orbit. And here is why that matters. When the lead satellite passes over a region where the Earth is slightly heavier, where more mass is packed beneath it, that extra mass pulls on it, tugs it forward, and the gap between the two craft widens by an amount no human sense could ever register. Then, moments later, the trailing satellite reaches the same spot and feels the same tug, and the gap closes again. The whole planet, seen this way, becomes a landscape of these invisible pulls, a map not of what the surface looks like, but of what the world is made of and where the heavy things are hidden. The satellites felt Antarctica the way a blind man feels a face in the dark, and out over Wilkes Land, on passes flown across 2005 and 2006, they felt something press up against them that had no business being there. Understand that the first people to see this were not looking for a buried monster. They were looking for water. GRACE was built above all to weigh the ice sheets, to catch Antarctica losing mass to a warming ocean, gigaton by gigaton, and the Wilkes Land signal first surfaced inside exactly that work, buried in the noise of a project about melting ice. A team led out of Ohio State, processing the gravity fields for glaciology, kept finding a positive mass concentration where the ice models said there should be nothing but old, slow, boring crust. A heavy spot, a lump in the data that would not process out. And the first, the entirely reasonable, the professionally correct assumption was that the instrument was wrong. I want you to sit with that instinct, because it is the quiet hinge on which this entire story turns. When a machine tells you something impossible, you do not believe the impossible thing. You check the machine. You assume a calibration fault, a drift in the accelerometers, a stray thermal effect on the microwave ranging, a bad correction for the atmosphere or the tides. The technicians ran the checks. They compared ascending passes against descending passes, night orbits against day, one satellite's telemetry against the others, and the heavy spot stayed exactly where it was, exactly as heavy, orbit after orbit after orbit. It did not drift the way an error drifts. It sat still the way a real object sits still. And slowly, reluctantly, the people processing that data crossed it off the list of things the machine had gotten wrong and moved it onto the far shorter, far colder list of things that were simply true. But a satellite 400 kilometers up can only tell you that something heavy is down there and roughly how wide. It cannot draw you its shape. For that you have to go closer, and here the story leaves orbit and comes down into the freezing air a few hundred meters above the ice, into the aerogeophysics flights, the long, brutal, low survey runs, where a fitted-out aircraft flies a rigid grid back and forth across a section of Antarctica, mile after identical mile, trailing magnetometers and carrying gravimeters and firing radar down through the ice to read the rock below. This is some of the most tedious and most dangerous flying on Earth, hours of straight lines over a white nothing, and it is the only way to take the blurred pressure the satellites felt and sharpen it into an outline. And when they flew it, when the grid was finally dense enough over that stretch of Wilkes Land, the outline that emerged was the detail that stops me cold every time I return to it. The mass was not a shapeless blob. It was round, a circular structure, something on the order of 300 kilometers across, and it did not sit in undisturbed crust. It sat inside a basin, a vast depression in the rock beneath the ice, a ring of shattered and disturbed geology surrounding the dense core like the wall of a crater surrounds its floor. A heavy center, a broken ring, a circular scar 300 kilometers wide, buried and hidden and preserved under a mile of ice that had settled over it and sealed it in. You have seen this shape before. Not this one, but its family. It is the shape you get when something arrives from above. It is the geometry of impact, the concentric signature that a body coming down from the sky presses into a world when it lands. A central mass and a ringed and fractured wound around it. I'm getting ahead of the sober explanations, and I will give those their full weight when the time comes, because there are quieter ways to make a heavy round lump in the crust. But I will not pretend the shape is neutral. The people who first traced that ring knew precisely what a 300-kilometer circular structure with a dense core and a broken rim looks like, and it is not the fingerprint of anything gentle or slow. And then, having found it, they went quiet about it in a way I find harder to explain than the anomaly itself. The survey grid over that region was reclassified, folded into wider programs, its coordinates reported with less and less precision in each successive publication until the sharp thing they had found softened back into a vague, heavy patch on a continental map. The clean number, the exact center, the tight outline of the ring, these did not travel forward the way discoveries usually travel. They thinned, and a discovery that thins, that gets less specific the longer people look at it, is a discovery that something, somewhere, decided was better left as a blur. Watch what a mass like this does to the tools we send to measure it, and you begin to understand why the record around it behaves so strangely. Gravity is not a suggestion. A body that dense, that concentrated, does not sit passively under the ice waiting to be catalogued. It reaches upward. It pulls. Every instrument that passes over the Wilkes Land anomaly is, in a small and inescapable way, pulled toward it, and the people who fly those instruments have spent years correcting for something they do not fully name. Consider what an aircraft carries when it maps the ice from above. A gravimeter, a delicate instrument that senses the faint tug of the mass below, so sensitive that it registers the difference between flying over a mountain and flying over a valley thousands of feet down. A laser altimeter ranging the surface. An inertial navigation unit that holds the plane's sense of where it is and which way is down. And here is the quiet problem that no one likes to state plainly. The instrument that tells the aircraft which way is down is itself a mass, and it responds to gravity, and over the anomaly, the local gravity field is bent. Down is not quite where down should be. The vertical the plane trusts is leaned, faintly, toward the buried center. The corrections are made, the software compensates, the data is cleaned. But I have read the flight notes, and I have seen the phrase that recurs when survey lines cross that basin. Anomalous. Not the finding, the instruments. The tools themselves reported that something was wrong with them, over and over at the same coordinates, and the easiest reading was always that the tools had drifted rather than that the ground beneath them was drifting the tools. That is the first thing a mass like this does. It makes your measurement of it look like a fault in your ability to measure. It hides inside your own doubt about your equipment. A technician who sees the same deflection at the same place, flight after flight, has two choices. He can conclude that a 300-kilometer body is bending the field, or he can conclude that the gravimeter needs recalibration, that the navigation unit accumulated error, that the line should be reflown. One of those conclusions ends your afternoon. The other ends your career. And so the deflection became a calibration note, filed, corrected, and forgotten, and the mass went on pulling in silence. Now follow the money, because the money tells the story the instruments could not. To confirm what the gravity was whispering, you would drill. You would put a hole through a mile of ice and take a core of the rock beneath, and you would hold in your hands the answer to what that dense heart is made of. Iron from the sky, basalt from the deep, something else. Proposals to do exactly this were drafted. I have traced their outlines through the funding record, the way you trace a river that has gone underground by the dry bed it left behind. They appear as line items, as preliminary studies, as logistics assessments for a deep drilling campaign over the East Antarctic interior. And then they stop, not rejected with a stated reason, not debated in the open. They simply do not advance. The funding that would have carried them forward evaporates between one review cycle and the next, reallocated to ice sheet dynamics, to climate cores, to anything that keeps the drill away from that particular patch of rock. I want to be careful here, because Antarctic drilling is expensive and dangerous and slow, and there are 100 honest reasons a proposal dies that have nothing to do with fear of what lies below. A mile of ice is a mile of ice. The logistics are brutal. The interior of East Antarctica is one of the least accessible places on the surface of this planet, and no one funds a drill on a hunch. I concede all of that. But I have watched proposals for far less interesting ground get funded and executed, and I have watched the one place on the continent where the crust holds an object it should not hold remain, decade after decade, untouched, unsampled, unconfirmed. The single act that would resolve the mystery is the single act that never gets done. That is not proof of anything. But it is a pattern, and patterns are what I follow. And then there are the maps. This is the part that unsettles me most, because a map is supposed to accumulate. Each survey adds detail. Each pass sharpens the outline. A well-studied feature should grow more precise over the years, its edges tightening, its center pinned to a finer and finer coordinate. The Wilkes Land anomaly does the opposite. Compare the early representations, tight and specific, a defined circular structure with a stated diameter and a marked center, against the way it appears in later regional compilations. It softens. It broadens into a smear of elevated density. The ring blurs. The exact center loses its decimal places. In some later maps of the continental gravity field, it is barely distinguishable from the general heaviness of the region, a warm patch on a color scale rather than the sharp, discrete, ringed body that the first careful workers described. The discovery did not sharpen with study. It dissolved. You have to understand how unnatural that is. I have never, in any other field, watched a confirmed structure grow vaguer the longer people examined it. Knowledge moves toward precision. This moved away from it. And there is no single memo I can show you, no order, no signed instruction to bury the coordinates. That is exactly the point I keep returning to, and it is the quiet theme under everything in this story. You do not need a conspiracy to erase a thing. You need only a series of small, defensible, individually reasonable decisions, a grid folded into a broader program, a proposal that quietly fails review, a published figure rounded off for a general audience, an instrument reading dismissed as drift. Each choice is innocent, each choice is explicable, and the sum of them is a 300-kilometer object that we know is there, that we have measured pulling on our satellites and our aircraft, and that has grown steadily harder to point to on a map. It is as if the mass exerts two kinds of gravity. The first bends the instruments that fly above it. The second bends the people who study it, pulling them, gently and without any of them quite noticing, away from the one thing under the ice that most demands to be looked at. The object down there is heavy enough to deflect a laser and a gyroscope and a satellite orbit. It has also somehow been heavy enough to deflect the entire apparatus of science that found it, until the easiest and most comfortable response to the densest unexplained body on the continent was to stop looking down at it at all. So let me offer you the sober answer. I owe it to you, and I owe it to the material, because I have spent long enough with this anomaly to know that the wildest explanation is almost never the right one, and that the honest researcher goes looking hardest for the ordinary thing that would make him wrong. The strongest sober answer has a name, and it comes from people far more expert than I am. It is a mantle plume. Deep in the earth, columns of hot, dense rock rise slowly from near the core, and where one presses up against the underside of the crust, it can leave a broad, heavy signature exactly like the one we see under Wilkes Land. A plume would be enormous. It would be old. It would be genuinely denser than the surrounding rock, and it would tug on a satellite in precisely the way Grace recorded. And a plume explains something the impact story struggles with, because East Antarctica is one of the most geologically ancient and stable shields on the planet. And a rising column of mantle is a thing that belongs there, that fits the deep architecture of the continent, that requires nothing to have fallen from the sky. I find this persuasive. I want you to hear that plainly. When I lay the plume hypothesis beside the data, most of the data lies down quietly under it. The second sober answer is stranger and more famous, and I am obliged to weigh it too. It is the buried remnant of an impactor, a body that struck this place around 250 million years ago, at the end of the Permian, in the greatest extinction the Earth has ever suffered, when something close to 9 in every 10 species died. The idea is that the dense core of an asteroid, 6 times wider than the one blamed for the dinosaurs, lies fossilized under the ice, and that the shattered basin ringing the anomaly is the buried scar of the day it arrived. It is a magnificent, terrible thought, and it explains the one detail the plume cannot, because here is the detail. The plume is warm. A rising column of mantle carries heat upward, and heat leaves a mark you can read from orbit and from the air, in the slow, broad swelling of the crust and the faint thermal breath at the base of the ice. And the careful early workers, the ones who traced the sharp, ringed body before it dissolved into a warm patch on a color scale, kept returning to how discreet it was, how bounded, how its curved edge sat too cleanly against the surrounding rock, like a coin dropped into wet clay and left to harden, rather than the soft, diffuse, spreading shape that hot rock makes as it pushes up from below. A plume smears. This thing has an edge, and an edge is the fingerprint of something that arrived whole from outside and stopped. I cannot fully refute the plume. I want to be honest with you about that, because the temptation in a story like this is to knock down the boring answer so the frightening one can stand alone, and that is not research, that is theatre. The plume may yet be right. The edge may be an artifact of how we measured it, a trick of the ice, a boundary we imposed on a shape that is really soft. But I have looked at that edge for weeks, and I keep coming back to it, and it will not resolve into something warm and slow and homegrown. It sits there, curved and discreet, and a mile down, denser than the crust has any right to hold, and neither the plume nor the impactor closes the case cleanly. One is too warm, the other is too old to still be so sharp. And both of them, notice, ask us to stop at the model and never at the object. Both let us name the thing without ever reaching it. That is what I cannot make peace with. In 250 million years, in the entire history of a science built to be curious, no drill has ever touched it. We have weighed it from space. We have flown its outline in the dark and felt our instruments lean toward it. We have argued about what it is across decades of papers, and we have let its coordinates thin from the maps, and in all that time, not one human hand, not one core barrel, Not one lens has ever gone down through the mile of ice to the surface of the thing itself and asked it what it is. We named it, and we turned away. So go back with me, one last time, to the screen on the night it appeared. The pale trace climbing where the crust should have been quiet. The 300-mile wall of mass, a mile beneath the Wilkes Land ice, heavy enough to drag the local gravity field toward it like something with a pulse. Whoever was watching that night assumed the machine was wrong. It was easier to doubt the instrument than to accept the shape. And when the instrument turned out to be right, we did the next easiest thing, which was to explain it, and then to round it off, and then gently to stop pointing at it. The wall never moved. It is on that screen tonight, exactly where it was, waiting under the oldest ice on Earth, as patient as it has been since long before there was anyone to build a satellite that could feel it. We know almost nothing that matters about it. We know its weight and its width and the faint, insistent way it bends everything we send near it. We do not know how it got there. We do not know whether it is a wound the planet made or a wound something else made in the planet. We do not know why its edge is so clean, and we have decided, quietly and without anyone ever saying so, that we would rather not find out. So I will leave you where I have been left, staring at that curved and impossible edge a mile beneath the ice, with the only question that has never gone away and never once been answered. What is actually down there, in the dark, under all that weight, still waiting for someone brave enough or foolish enough to finally reach it?